Good morning, students. Today we will discuss Weingarten equations. Weingarten equations are the equations which gives the derivatives of normal unit vector to a surface in terms of the fundamental coefficients E, F, G, L, M, N. These are the 6 fundamental magnitudes which we have already studied. Now, the Weingarten equations are given by the first equation is h square n1 is equal to fm minus gl into r1 plus fl minus em into r2. Second Weingarten equation is h square n2 is equal to fn minus gm into vector r1 plus fm minus en into vector r2. Here n1 is the partial derivative of normal unit vector n with respect to u parameter, and n2 is the partial derivative of normal unit vector n with respect to the parameter v. r1 and r2 are the tangential vectors to the surface. r1 is curl r by curl u, r2 is curl r by curl v. Now, in order to prove this, firstly we will use the result which you have already studied in the vector calculus. If we have a vector of constant magnitude, then its dot product with itself, that is 0. So by using that result here, because vector n, that is a normal unit vector to the surface, this is unit vector, so its magnitude is 1. So it means its magnitude is constant, therefore its dot product with its derivatives, that will be 0. Therefore we can say that vector n1 and vector n2, these are perpendicular to vector n. Because these are perpendicular to n, therefore we can say that the vectors n1 and vector n2, they lies in the plane of the vectors r1 and the vector r2. Because the vectors r1 and r2 are tangential vectors to the given surface. Thus we can say that the vectors n1, vector r1, vector r2, they are lying in the same plane. So these are coplanar vectors. And also the 3 vectors, vector n2, vector r1, vector r2, they are also lying in the same plane. They are coplanar vectors. Now, if the vectors are coplanar, then one of them can be written as the linear combination of the other two. So, we can write vector n1 and r2, vector n1 and vector n2 in terms of the vectors r1 and vector r2. So, vector n1 can be written as ar1 plus br2. Here a and b are scalars. In the same way, vector n2 can be written as cr1 plus dr2. Here c and d are scalars. Now let us consider this equation 1. So taking the equation 1 and taking the dot product of equation 1 with vector r1 and then with vector r2. So let us first take in this equation dot product with vector r1 on both sides. So here dot product with r1, that gives n1 dot r1. On the right hand side we get a r1 dot r2 plus b r2 dot r1. Now taking dot product with vector r2 in this equation. Now if we do dot product with r2, this will become n1 dot r2. Here we get a r1 dot r2 plus b r2 dot r2. Now because the vectors n and vector r1, these are perpendicular vectors. Because the vector n is normal unit vector to the surface, r1 is tangential vector to the surface, these two vectors are perpendicular vectors, so their dot product will be 0. Now we differentiate this equation partially with respect to u and then partially with respect to v. So one by one doing the differentiation. Firstly we will differentiate this equation partially with respect to the parameter u. So by using product rule of differentiation, the vector n dot r11 plus the derivative of n with respect to u, that is n1 dot r1, and is equal to 0. Now differentiating this partially with respect to parameter v, and as it is dot r1 का v के रिस्पेक्ट में पार्शियल डेरिवेटिव दैट विल आर r12 प्लस n का v के रिस्पेक्ट में पार्शियल डेरिवेटिव दैट इज n2 dot r1 is equal to 0. So differentiating this equation with respect to u and v partially, we get these two equations. Now we have already derive the results that n dot r11 that is L, n dot r12 that is M. So we can use these two results here. Using these results in these two equations, from here we get n1 dot r1, this is minus L, and n2 dot r1 that is minus M. So using all these results in equations 3 and 4, so the equation 3 will become, now this is minus L, this is A, r1 dot r1 that is E, r2 dot r1 that is F. So this equation will become minus L is equal to AE plus BF. In the same way, equation 4 gives us, this will become minus M, r1 dot r2 is F, r2 dot r2 is G. So we get minus M is equal to AF plus BG. So we have obtained the two equations which we have denoted by equations 5 and equation 6. Now we can solve these two equations by using cross multiplication method. So we get A upon the product of Fm with the product of Fm minus GL, then B divided by the product of FL minus EM, then 1 divided by the product of EG and FF. So we get EG minus F square. So from first and third member we get value of A, which is Fm minus GL divided by X square, and from these two members we get the value of B, which is FL minus EM divided by H square. We have obtained the values of the scalars A and B. Now we can substitute the values of A and B in the equation 1 to get the first Weingarten equation, which gives the derivative of normal unit vector n to the surface with respect to the parameter u. So we get h square n1 is equal to Fm minus GL into R1 plus FL minus EM into R2. So this is our first Weingarten equation. Now to find the second Weingarten equation, we again do the dot product of the equation, which is n2 is equal to CR1 plus dr2. We will do its derivative partially. We will take dot product in this equation with vector r1 and vector r2 one by one. So first we do the dot product with vector r1 on both sides. So this will become n2 dot r1. Here we get C r1 dot r1 plus d r2 dot r1. If we do the dot product with r2 on both sides of this equation, we get n2 dot r2 is equal to cr1 dot r2 plus dr2 dot r2. Now we know that the normal unit vector to the surface and tangential vector to the surface, these are perpendicular to each other. So n dot r2, that will be 0. Now from here, differentiating with respect to the parameters u and v partially. So firstly, let us differentiate this equation partially with respect to parameter u, and as it is, derivative of r2 with respect to u, that is r21, plus derivative of n with respect to u, that is n1 dot r2 as it is equal to 0. Now if we differentiate this equation partially with respect to v, and as it is, derivative of r2 with respect to v, that is r22, plus derivative of n with respect to v, that is n2 dot r2 is equal to 0. Now we use these results because n dot r21, that is m, and n dot r22, that is n fundamental magnitude. So substituting these values in these equations, we get n2 dot r1, n2 dot r1 is equal to minus m, and n2 dot r2 is equal to minus n. Now using all these values in these two equations will become, on the left hand side, this is minus m c into r1 dot r1, that is E, plus d as it is r2 dot r1, that is f. From the equation 9, n2 dot r2, that is minus n, c as it is r1 dot r2 is f, plus d as it is r2 dot r2 is g. So we have obtained the two equations, CE plus DF plus M is equal to 0, CF plus DG plus N is equal to 0. Now we can solve these two equations by using cross multiplication method to get the values of the scalars C and D. So by using cross multiplication method here, C upon we get Fn minus Gm, D divided by Fm minus En, 1 divided by Eg minus F square. So from first and third member we get the value of C, which is Fn minus Gm divided by H square. From the last two members we get the value of D, which is Fm minus En divided by H square. So we have obtained the values of the scalars C and D. Now we can substitute these two values in the equation 2. Equation 2, which was N2 is equal to CR1 plus TR2. So substituting the values in that equation, we get second Weingarten equation, which is H square N2 is equal to Fn minus Gm into vector R1 plus Fm minus En into vector R2. So these were the Weingarten equations, which gives derivatives of normal unit vector to the surface in terms of fundamental magnitudes. Next we deduce a formula by using Weingarten equations, which is H into N1 cross N2 is equal to Ln minus M square into N. We have to prove this result. In order to prove this result, we will do the cross product of the Weingarten equations, which we have already obtained. So doing the cross multiplication, on the left hand side we get H square N1 cross H square N2. On the right hand side, taking the cross product of the two expressions, here H square, these are scalars, so that will become H raised to the power 4, N1 cross N2. Because N1 and N2 are vectors, so their cross product will be N1 cross N2. On the right hand side, using R1 cross R1, that will be 0, R2 cross R2, that will also be 0, and R1 cross R2, that will be H into N, and R2 cross R1, that will be minus Hn. So using all these results here, the right hand side becomes F square M square minus EF Mn minus GL Fm plus GL En minus F square Ln plus FL Em plus Em Fn minus Eg M square into Hn. Simplifying the expression inside the bracket, we get F square into M square minus Ln plus Eg into Ln minus M square into Hn. Now taking Ln minus M square common from these two terms, inside we get Eg minus F square, and this is Hn. And now what is Eg minus F square? That is H square. So we get H square into H, that will be H cube. So right hand side becomes Ln minus M square into H cube N. So now cancelling H cube from both sides. On the left hand side we are left with H into N1 cross N2. On the right hand side we get Ln minus M square into N. So this is the formula which we have derived with the help of Weingarten equations.